Good morning, class 10. Today we will study chemical bonding, chapter number 2. Okay. Before we start, let us have some idea about an atom. What is an atom? An atom is the smallest particle of an element that can take part in a chemical reaction, as we all know that. I've been telling you since class 7. Now, the three subatomic particles in an atom are the protons, the electrons, and the neutrons. Protons are positively charged particles, the electrons are negatively charged particles, and neutrons, they do not have any neutron. Now, there is a force of attraction between the nucleus, where the protons exist, and the electrons. The nucleus has, the central part of an atom is called the nucleus, and we have protons, the positively charged particles, and the neutrons does not have any charge, the neutral particles. And then around the nucleus we have orbit or the shell, and in each shell we have electrons. We have electrons. So electrons revolve around the nucleus in a very high speed. And let me remind you that the number of protons in an atom is equal to the number of electrons in a particular atom of a particular element, depending upon the atom. Again, atomic number is the number of protons in an atom. Just a revision for you all. Now, when we talk about the electronic configuration, okay, let us start. Let me tell you what an electronic configuration is. An electronic configuration is the distribution of electrons in the various shells in an atom. It is the distribution of electrons. So in the first orbit, in the first shell, the maximum you can have in the first, maximum number of electrons we can have in the first shell are 2 electrons. In the second shell, maximum we can have is 8, and the remaining in the third. Okay, like in the third shell we have 2n squared, the formula. 2 into n is 3 squared. So 2 into 3 is 9. So we have already done this earlier. We have 18 electrons. This is how we calculate. Just a reminder for you all. Okay. So now, depending upon the electrons in the last shell, we can classify the elements into metals and non-metals. Over here we will talk about metals and non-metals. So metals will have, this is very, very important for you now, metals will have 1 or 2 or 3 electrons in the outermost shell or the valence shell, and non-metals will have 5 or 6 or 7 electrons. Okay? And metalloids will have 4 electrons in the outermost shell. Okay? So if an atom of an element will have 1 or 2 or 3 electrons in the outermost shell, it means that it is definitely metals. And if an atom has 5, 6 or 7 electrons in the outermost shell, it means non-metals. If it has 4, then we call it metalloids. Now what about the fourth type of element? The fourth type of element are noble gases or inert gases. Will have 8 electrons in the outermost shell. Or helium. Remember, helium will have 2 electrons in the, helium is the only inert gas or a noble gas which has 2 electrons in the outermost shell. That means it follows the duplet theory, having 2 electrons in the outermost shell. Rest of the inert gases, helium, neon, argon, krypton, xenon, and radon. Except for helium, rest of them will have 8 electrons in the outermost shell. Okay, now this much we have understood. Metals will have 1 or 2 or 3 electrons in the outermost shell. Non-metals will have 5 or 6 or 7 electrons in the outermost shell. Metalloids will have 4 electrons in the outermost shell. And the inert gases, helium for that matter, will have 2 electrons, and rest of the 5 inert gases will have 8 electrons in the outermost shell. This is all about the electrons in the outermost shell of different types of elements, atoms of different types of elements. Now, when we talk about the metals, the non-metals, and the metalloids, we have unstable electronic configuration. Stable electronic configuration means having 8 electrons in the outermost shell, or in the case of hydrogen or helium, 2 electrons in the outermost shell. Okay, helium will have 2 electrons in the outermost shell, so hydrogen will try to have the electronic configuration of helium, its nearest noble gas. So rest of the elements, whether it's a metal or a non-metal or metalloids, will try to have 8 electrons in the outermost shell. It will try to have the electronic configuration of its nearest noble gas. That means having 8 electrons in the outermost shell. So, atoms of elements other than noble gases have unstable electronic configuration. That is, the outermost shell is incomplete. It does not have 8 electrons in the outermost shell. So, they either lose or gain or share electrons. Okay, so that is the chemical reaction. So why do elements combine? When we say, why do elements combine? Elements combine to have the electronic configuration of the nearest noble gas. So how do elements combine? Why do elements combine? I told you, why do elements combine to form molecules? Why is there chemical reaction between the elements? To have 8 electrons, either in the outermost shell, either by sharing, either by transfer. Okay? Now, having 8 electrons in the outermost shell is very, very important, that to have a stable electronic configuration. So they either follow, to have 8 electrons in the outermost shell, they either follow duplet rule or octet rule. So there are 2 methods to have 2 electrons in the outermost shell or 8 electrons in the outermost shell. Having 2 electrons in the outermost shell means they follow duplet rule, whereas having 8 electrons in the outermost shell means they follow octet rule. Okay? Now, there are 2 ways in which elements combine. They gain electrons or they lose electrons. That is electron transfer, either by electron transfer or electron sharing. So, before we go any further, I just want to tell you again, why do elements combine? Elements combine to have stable electronic configuration. Number one is, there are 2 ways. There are 2 types of compound. One is electrovalent compound and the other is covalent compound. Electrovalent compound and electrovalent compound and covalent compound. Electrovalent compound is formed by the sharing of transfer of electrons, whereas covalent compound is formed by the sharing of electrons. Now, today we will deal with electrovalent compounds. Okay? In the next class, we'll talk about covalent compounds. So, electrovalent compounds. Now, electrovalent compounds are always formed between metal and non-metals. Electrovalent compounds are always formed between metals and non-metals. If there is a combination, if there is a reaction between a metal and a non-metal to form a totally new compound, then it has to be electrovalent compound by the transfer of electrons. So when we say transfer of electrons now, we are confused. Who receives electrons and who gives electrons? Who donates electrons? Metals always lose electrons, okay? And non-metals always gain electrons. So metals, they lose, they always give electrons. In a simple language, just to understand, metals give electrons, whereas non-metals receive, will give, and this is gain. Metals will give electrons and non-metals will receive electrons, or it will gain electrons. Okay, now why is that so? To have stable electronic configuration. So let us talk about, let me tell you the first one, example of the first electrovalent compound. We will deal with sodium chloride, the formation of sodium chloride. The formation of sodium chloride. Okay. Now sodium, the atomic number of sodium, it will be given to you, no need to remember. If you can, it's okay. Atomic number of sodium is 11. And for chlorine, atomic number is 17. It's a halogen. Fluorine, chlorine, bromine, iodine. They are halogens. So chlorine, atomic number is 17. So what will be the electronic configuration of sodium? It will be 2 in the first orbit. The second shell will have 8 electrons, and together it is 10. How many electrons are there? 11. So total 2, 8, and remaining 1 here in the outermost shell. As I told you, metals will always have 1 or 2 or 3 electrons in the outermost shell. Since sodium will have 1 electron in the outermost shell, therefore sodium is obviously a metal. Now chlorine, atomic number is 17. What will be the electronic configuration? 2, 8, and 7. As I already told you earlier, that non-metals will have 5, 6, or 7 electrons in the outermost shell. So therefore, chlorine is a non-metal. Now, as I already told you, now we are interested only in the last shell, or the valence shell of sodium. We are interested in the valence shell of sodium. How many electrons does it have? 1 electron in the outermost shell. So this dot represents the orbital electron, the last one. Valence electrons, the electron in the valence shell. So since it has 1 electron in the outermost shell, it is a metal. All right. Now we deal with the atom of chlorine. How many electrons will chlorine have in the outermost shell? Since it is a non-metal, it will have 7 electrons in the outermost shell because the atomic number is 17. So 1, 2, 3, 4, 5, 6, and 7 electrons. These crosses represent the electrons of chlorine, the valence in the valence shell. The valence electrons of chlorine, the electrons in the valence shell. Now, sodium is a metal, chlorine is a non-metal. And there is a chemical combination between the sodium, metal, and a non-metal. Now, metal always gives electrons. It is easier for, how many electrons does sodium have? 1 electron in our outermost shell. Is it easier for sodium to give 1 electron or to receive 7 electrons from chlorine? Obviously, it is easier for the sodium to give 1 electron to chlorine. Now, after it gives 1 electron How many electrons will sodium have? Will have, it will, this one electron is given to chlorine atom. So it will have 2, 8. Electronic configuration becomes 2, 8. Chlorine, how many electrons will it have? 2, 8. After receiving, it has 7 electrons in the outermost shell. So since it receives 1 electron from sodium, how many electrons will chlorine have now? 8. So both of them, after sodium gives 1 electron to chlorine, sodium will have 8 electrons in the outermost shell, and chlorine, after receives 1 electron from sodium, it will have 8 electrons in the outermost shell. So this is how there is a combination, the chemical bonding between sodium chloride. So what is the bond? Electrovalent bond. What is the bond? The electrovalent bond formed by the transfer of electrons. Who gives electrons? Sodium gives electrons, or the metal gives electrons in this case, and over here the chlorine, the non-metal, will receive electrons to have the stable electronic configuration now. 2,8 in the case of sodium and 2,8,8 in the case of chlorine. Now, if you see, how many electrons will sodium have? Now, obviously, 10. 10 electrons. 10 electrons now. Earlier, it had 11 electrons. Now, it has 10 electrons after losing 1 electron to chlorine. How many protons does it? How many protons does it have? Protons, how many does it have? 11 protons. So since it has 1 proton more, 1 positive charge more, the sodium becomes sodium ion now, Na+. Is it okay? Now, in the case of chlorine, how many electrons will chlorine have? Chlorine will have, when we talk about chlorine, chlorine actually had how many? What is the atomic number? 17. How many protons does it have? 17. How many electrons did it have? Electrons earlier, before receiving 1 electron from sodium. It had 17 electrons, but now after receiving 1 electron from sodium, it will have 18 electrons. 18 electrons. So that means it has 1 electron more. So therefore, it becomes chloride ion, Cl-, because it receives an electron from sodium. So it becomes chloride ion. Okay. And between this Na+ and Cl-, these are ions now. These ions are held together very strongly, let me tell you, by the electrostatic force of attraction. Okay? The ions are held together by the very strong electrostatic force of attraction. So, and forms sodium chloride. Okay? So now, we have other, I can give you other examples also, but since there is not much time left, we will continue in the next class. So today, we talked about the atom. Atom is the smallest particle of an element that can take part in a chemical reaction. And there are 3 subatomic particles: protons, electrons, and neutrons. Protons are positively charged, electrons are negatively charged, neutrons are neutral, does not have any charge. The entire charge of the nucleus, because of the protons, is positively charged, and electrons, they are negatively charged. Now, metals will have 1 or 2 or 3 electrons in the valence shell, whereas non-metals will have 4, 5, 6, 7 electrons in the valence shell. And if it has 4, we consider it as metalloids. Now, there are 2 types of chemical bonding. Number 1, electrovalent bond and covalent bond. Covalent bond is formed by the sharing of electrons, and it takes place between non-metals only. Covalent bond takes place between the non-metals only, whereas electrovalent bonds is formed by the transfer of electrons, and it is formed between a metallic atom and a non-metallic atom. Non-metals always receive electrons, whereas metallic atom always lose electrons. It gives electrons. Who receives electrons? It is the non-metal. Since there is a loss and the gain, loss of electrons by the metal and gain of electrons by the non-metal, it forms ions. So metals always, please remember, metals always, since it loses electrons, it always forms positively charged ion, whereas non-metal, in this case it is chlorine, it forms a negative ion. Okay? Now, why do elements combine? So we discussed about that earlier. Why do elements combine? Elements combine together to form molecules, to attain the stable electronic configuration of its nearest noble gas. So with that, we come to the end of the chapter, the lesson today. We will continue more of electrovalent compounds, okay, in the next class. So bye for now. Thank you so much.